Okay, so in this video, let's understand what the random forest algorithm is. So, random forest is one of the most popular bagging techniques, okay? It's one of the most popular bagging techniques, and it's probably the most exploited and used machine learning model. I mean, I've seen a lot of teams and companies use random forest for their classification or regression algorithms, models, sorry. So, what is a random forest? I'll tell you. So, the name random forest, forest is like a bunch of trees together, right? So, and random, so basically, forest is a bunch of trees, and basically, the name comes from decision trees. So, what random forest does is you use a lot of decision trees as your base models or your base learners in the model, in the random forest model. And the name random comes from bagging, where you use random sampling with replacement. So that's how the name random forest comes. Uh, and it's important to note that in random forest, your base learners are only decision trees, okay? Are only decision trees, right? So what is a random forest? A random forest algorithm is basically your decision tree, which is your base learner. Random forest does not use anything else, plus bagging. Bagging is your sampling the rows with replacement. Plus, there's one more aspect to random forest. It's called column sampling. Okay, so I'll explain what this is in a minute. And this is without replacement. Okay, look, bagging is with replacement, but column sampling is without replacement. Okay, now why is it without replacement? Is because I'll explain this to you. Just give me a minute. So let's say you have a dataset dn, and the total number of rows in your dn is n, and the total number of dimensions in dn is d. Okay, so what you do is you use something called bootstrap aggregating plus column sampling, which is feature sampling. Okay, so you use bootstrap plus feature sampling. Now what is feature sampling? Let's say I have features f1, f2, all the way to fn over here. So instead of taking all the features in my data set D and dash, what I'll do is I'll take only a sample of these features, maybe F1, F4, F7, F8, F10. That's it. That will be my features. And this is without replacement, okay? And obviously row sampling, this is row sampling, right? Bootstrap. So this is row sampling, this is column sampling, right? And obviously the number of rows, let's call the number of rows as n dash. So n dash is less than n, and the number of columns is d dash, right? So d dash is also less than d in your random forest models. Okay, so now the important question is, why is column sampling without replace? Sorry, this is without replacement. Okay. So the important question here is, why is column sampling without replacement? Well, the answer is that, if you use replacement and you get two similar columns in your dataset D and dash, what can happen is that can lead to collinearity. Okay. Basically, then you have strong correlations between two different features in your dataset, which leads to the model actually performing very worse, performing very, very bad, right? So you don't want collinearity in your data set, and that's why you don't use column sampling with replacement. Whereas now you might ask, why do we use row sampling with replacement? Bootstrapping, it's row sampling with replacement. Why is that? I don't think I explained this in the last video, but the answer to this is that, look, this data set is basically a sample of our entire population, right? So row sampling with replacement ensures that we have the distribution is not the same in your in your sub data sets dn1, dn2, dn3. These are your sub data sets. So row sampling with replacement ensures that the data sets I call them sub data sets. Okay, that means after sampling you get a data set d and dash. Those are sub data sets. So it ensures that the sub data sets have different distributions. Okay, which ensures that the model is exposed to varying varieties of data sets, so it can learn better, right? If it has different data sets to learn from, it'll learn better, and it'll probably it'll probably acclimate better to different data sets and changing varieties of the data set. So that's why we use row sampling with replacement. Sorry, we use row sampling with replacement, right? So that's what random forests are about. So intuitively, if you want to think about it, column sampling makes models very different and reduces variance extensively. Okay, so column sampling. So if I have some 5 columns over here, I'll have different columns in, let's say, D and 2, right? I'll have different columns over here. So column sampling makes models very different from each other. Very different from each other. And row sampling with replacement ensures that the distributions of your data sets aren't exactly the same, they're a little different, which helps the models, these different base learners, learn very well and to changing varieties of data. Okay, so now the that if you have dn and you row sample plus column sample this, and you get dn1, then you do it again, you get dn2, all the way to you get dnk, right? And all your base learners m1, m2, all the way to mn, these are all dts, right? And then you again aggregate it, and this gives you the final answer. This is the main model m, which is the aggregating model, and it gives you the final answer, right? So the DTs here are of reasonable length, almost full depth, because the RF random forests will automatically reduce variance. So we don't have to worry about the depth of the decision tree and the fact that it will overfit, because this bagging scheme will automatically reduce variance in your DTs. So DTs here are of maximum depth. Okay, so now there's one more concept that we need to learn. It's called out of bag points. Okay, so look, if I have this is my total data set dn, and I'm making a sub data set dn dash over here, right? So look, let's say I have rows in my sub data set. Sorry, in my data set, I have row 1, row 2, row 3. Let's just ignore column sampling for now. Let's just concentrate on row sampling. So, I take one row from here, and then I make it my first row in dn dash. Then I take one row from here, and then I make it my second row in dn dash. So what happens is only a particular set of rows will, they will get, only a particular set of rows will get, will be a part of dn dash. Not all of them will be a part of dn dash. There will be some rows, let's say, all of these rows that weren't a part of this dn dash, right? Yeah, these rows weren't a part of dn dash. So what we can do is, in fact, a lot of models and a lot of libraries do this, is that, so these, basically the rows that aren't a part of dn dash, they're called OOB points, okay, out of bag points, right? So these points that are not a part of dn dash are called out of bag points. So what models do is they use these out of bag points as your cross validation data set for this particular model. So you have this dn dash, and then you make model m1, which is a decision tree. So you use these out of bag points as your cross validation data set to your model m1. Okay, And in fact, a lot of models give you out of bag error. If you've used scikit-learn or some other libraries, you would have come across this uh, term out of bag error, which is the error that which is the error of your which is the error that you get from the model on your out of bag points. Okay, out of bag error. It helps you decide how well the model is actually performing on unseen data or on cross validation data. Okay, so you use the out of bag points as the cross validation data to your model M1 to see how well is it actually performing using the out of bag error. Okay, so I'll stop random forest here and I'll see you guys in the next video.